Today's session will be about configuring a Kubernetes fleet using Open Cluster Management. I'm Matt Prale. I'm the Open Cluster Management Policy SIG lead. I'm also a principal software engineer at Red Hat. So this session hopefully will show how you can transform your organization's Kubernetes multi-cluster management using Open Cluster Management or OCM policies. And this session will go over the basic API concepts to help you get started and show a couple demos that show some scenarios where this might be useful for you. If you're not familiar with Open Cluster Management, it's an open source CNCF sandbox project, and its main goal is really to simplify the management of Kubernetes clusters. So it has a hub and spoke architecture, meaning that there is a central hub that manages all of your Kubernetes clusters, which we call managed clusters. And so all the status aggregation and such, and all of the instructions that the managed clusters pull from are on the hub. It allows targeted distribution of Kubernetes manifests from the hub, and it's also an integration point for making Kubernetes capabilities multi-cluster aware. Today we'll be talking about the Policy Addon, which is an add-on that utilizes the integration points that Open Cluster Management provides. So as I alluded to in the last slide, the OCM architecture looks like this, where you have a hub cluster, and then there's this little box called a cluster manager that has some of the bits that allow the managed cluster to be registered to the hub. And then on the right-hand side, you'll see management add-ons. So those are the layers on top of Open Cluster Management to take advantage of your clusters being registered to the hub. And so, like I said, we'll be talking about the policy add-on today, but there's the application add-on, there's search, there are many others. And so, as you can see, in this example, we have two clusters being managed by the hub, so cluster 1 and cluster 2. And there's some registration pods that are running that connect back to the hub, but also the add-on agents. So if you have the policy add-on installed, there'll be some Kubernetes controllers that are installed on the managed cluster to be able to perform the tasks you desire. So before diving into the policy add-on, some of the challenges around multi-cluster governance is really having that consistent configuration management, especially if you have like a multi-cluster or multi-cloud environment, or you have Kubernetes clusters that are spun up frequently and then torn down frequently. You need an easy way to categorize those clusters and determine which configuration should apply to them. But also meeting organization security standards. So if you have internal or external regulatory compliance and your Kubernetes clusters need to be configured a certain way, or you need to prevent certain user actions where RBAC prevention or least privilege doesn't do it, then you'll need some other tool, such as an admission controller. It's also hard to find like an open extensible solution to do this and accounting for that fluidity of cloud environments. So the Open Cluster Management Policy Add-on works by providing declarative policies. It's a YAML that you would normally do like kubectl apply for, or use say Argo CD or whatever you might use to apply YAML to your cluster. And it provides that configuration management in a multi-cluster environment. It informs or enforces Kubernetes manifests on desired Kubernetes clusters, and there's templating around that to make it dynamic, so you can pull values from either the hub cluster or the managed cluster to determine how to configure your cluster while using the same policy. And one of the cool features that has been added in the last year or so is secure secrets distribution from the hub to managed clusters, which will show a demo on that. It can wrap other policy engines, and so specifically we have native support for Gatekeeper. So if you utilize our policy add-on to distribute Gatekeeper constraints, the audit results from Gatekeeper will be sent back to the hub, so you can have a single view of all of the audit results of your Kubernetes fleet for that Gatekeeper constraint. I won't go over that specific bit in this session, but we do have some documentation on the Open Cluster Management community website going over this. We also have an extensive collection of policies at the policy collection repository. So if you're interested in taking a look at some recommended policies or just example policies, that's a great place to start. So before diving into the demo and showing you some YAML, I just want to go over a few concepts within the OCM Policy API. So the first layer that I would start with is policy templates. So this is separate from the templating I talked about in the previous slide, where it allows you to specify dynamic value. These are the actual desired checks or action that you want to take. And today we'll be talking about configuration policy, but we also support gatekeeper constraints, and there are some other third parties that have their own controllers, that policy engines that integrate with this. And so again, a policy template is really the desired check or action that you want to take, and that's what actually gets applied to the managed cluster. So a policy, it's a YAML that groups these policy templates together. So it's an envelope that allows you to distribute those configuration policies or gatekeeper constraints to the managed cluster. And then the status aggregation goes back into that policy envelope. And if you're not familiar with placement, it's an open cluster management concept that allows you to select a cluster, all clusters, or a subset of clusters that a certain action should be applied to. I'll show this in the demo, but say you have different data centers that your managed clusters live in, and you want to have a policy that applies to only a specific data center. You can do that by defining a placement, and then the placement binding will tie a placement to a policy, which I'll show in the demo. And then there's another grouping mechanism for policy objects called policy set, but I won't go over that right now. But it is useful to deploy a group of policies together using a single placement and having some high-level aggregation of status in that one policy set. So let's go ahead and show the demo environment. So I have a Visual Studio Code up, but for now, let's go to the command line. So I have 3 kind clusters up. So I have the hub, like I showed you in the OCM architecture slide, and then cluster 1 and cluster 2 are registered to the hub. So let me just make sure that I'm connected to the hub. So I can do kubectl get managed clusters. And you can see that on the hub cluster, I can see cluster 1 and cluster 2 are registered. Now, let's take a look at the YAML of those. So you can see that you can specify labels on these managed cluster objects, and this is how you can filter which clusters the policy applies to. So in this case, I only added this custom label called Data Center of Raleigh for cluster 1. And if I go down to cluster 2, I added Data Center of Boston. So you could add as many labels as you want to kind of further filter and select which clusters a policy applies to, but for the sake of this demo, I'm just showing you these. All right. So the first example that we'll show is example 1. So I'll go ahead and apply that YAML right now while we're talking about it. So this is the policy envelope I was telling you about. So it's not the actual thing that performs the action, but instead it kind of has a group of policies that can take the action. So in this case, I have this policy templates array, and I have just one policy template, which is a configuration policy that is informing that we must have this config map called dev.conf.demo in the default namespace, and it must have this movie quote of do or do not, there is no try. So again, like I said before, there's inform and enforce. So inform will just tell you whether the config map on the managed cluster matches this. Enforce would actually go ahead and create or update it if it didn't match. So I mentioned must have here, but you can actually do must not have. So if you wanted to make sure there wasn't a config map that looked like that, and then in enforce, it would actually delete it. And then there's must only have as an option. If I had this, for example, and there was a separate key, then in the config map, if I remove that with must only have, it would actually delete that key. Whereas if I'm just doing must have, it is doing a merge. So any other keys that exist already on the config map would be retained. It'd just be this movie quote would be set. So as I mentioned before, placement is a way to select clusters that the policy should apply to. So in this case, I'm just doing a label selector, and I'm saying that any cluster that has the data center set to Boston, this policy should apply to. So as you recall, I had cluster 1 that was set to the data center of Raleigh, and then cluster 2 had the data center set to Boston. So we're only going to be targeting cluster 2. And then the last bit is that placement binding, where it's tying the placement that I defined below and the policy. So it's going to say, distribute this policy to the clusters that match this placement. All right, so let's take a look at our policy. So we can see that we have this one policy that we defined, and it's come back as non-compliant. So let's go ahead and take a look why. So we can see that it applied just to cluster 2, and cluster 2 is non-compliant. Now, if I had cluster 1 also applied, there would be another entry here. And one of the side effects of creating a policy and tying it to a placement is that copies of the policy, which we call replicated policies or sometimes propagated policies, are copied into each managed cluster namespace. So because it applied to cluster 2, there's a namespace on the hub called cluster 2. And if I get the policy there, you can see that there's a copy of it. So this is the namespace I defined what we call the root policy here, and then the policy name. So that's how they're named in the managed cluster namespace. So what I can do is I can get the YAML of that, and then I get some more detailed status about why the configuration policy came back non-compliant for that cluster. So in this case, it's saying the config map devconf demo was not found in namespace default. So what I can do is edit that policy. So this is the root policy, not the replicate policy in managed cluster namespace, but the root policy that we applied earlier. And I'll just change this remediation action to enforce. And so now it's come back as compliant. So we'll look at that replicate policy in the cluster 2 namespace again. And we can see that history showed that it was non-compliant at this timestamp, but it now is compliant because it was created successfully in namespace default. And so this, the way this currently works right now is that the configuration policy will be evaluated every 10 seconds, so you can modify this with a field called evaluation interval. We are in the process of looking to see if we can make this event-driven using watches instead, or as an option, but that's further on in the roadmap. But you can see that it created it, so it's compliant, and then it verified it again later. So now it's been verified that it's still correct based on what we have in the configuration policy. And now I'll just change over to the managed cluster, so cluster 2. So if we get config map, you can see that the devconf demo config map was created on the cluster. we can see that the movie quote was set. So one other thing to note too is that on the managed cluster side, if we go to the managed cluster namespace, you'll see that just like on the hub, there is this managed cluster or this replicated policy. So the way it works is that the hub puts a replicated policy in the cluster 2 namespace, and then the managed cluster only has access to pull policies from the cluster 2 namespace on the hub. It pulls it down, and then that's what actually gets looked at by the managed cluster. And if you recall, our policy template had a single configuration policy. So I'll show you that the configuration policy was created from that policy envelope that I showed you before. And there's a little bit more detail here if you're interested in that. But the status gets aggregated to that policy. And so the reason why we copy it down to the managed cluster is so that in case the managed cluster is disconnected from the hub, it can still process its policies and record the status. And then when it connects back to the hub, it'll send that status back to the hub cluster and sync back. All right, so going back to our slides. I'll just go a little bit over the OCM policy architecture like we talked about before. Well, I kind of showed it to you in the demo, but we defined that root policy when I did that kubectl apply for example 1.yaml. There's a component called the policy propagator, which watches that root policy and then determines based on the placement that is associated with the policy, it'll create the replicated policies in the managed cluster namespaces. And then on the managed cluster side, there's some controllers that will sync that down. And then the policy templates will get created on the managed cluster. And then there's controllers. In this case, we're doing configuration policy. So there's a config policy controller pod that was watching those configuration policies and evaluating the policies and sending back status updates to the policy, which then get propagated back to the hub cluster. So one of the really cool features about OCM policies is policy templating. And so it allows you to have dynamic configuration policy definitions, and it uses the Go text template syntax, which is pretty similar to Helm. So we have a lot of similar template functions as well that you might have been used to with Helm. And so there's two types of template functions. There's some on the hub, and then there's some for the managed cluster. So if you see curly brace hub, that means that the template will be executed on the hub, and the value will be stored in the replicated policy in the managed cluster namespace on the hub after the template is resolved. So this is helpful if you're trying to copy data from the hub, or if you want to configure things slightly differently for each managed cluster based on some data on the hub. And then on the managed cluster side, there's, if you just see the double curly brace, that gets executed whenever the policy is evaluated on the managed cluster. And so some example template functions that I showed below, you can grab a field from a config map on the managed cluster, or you can get a field from a secret on the hub and copy that down securely to the managed cluster, or you can just do a generic lookup where you can look up, this is on the managed cluster side, you can look up any object on the cluster and grab a field from it to specify in your configuration. One thing I'll note is that with the hub policy templates, you're limited to just querying for objects in the same namespace as your root policy. And this is for security reasons, so that there's not this privilege escalation where if you have access to create policies on the hub in one namespace, it doesn't allow you to just query anything on the hub cluster. So again, any objects that are in the same namespace as the root policy that you defined, you can access those with hub templates. So the next demo will be showing securely copying a secret value from the hub to all managed clusters, and each value is specific to that cluster. So we have cluster 1, cluster 2 registered to the hub, and so they'll each get a different value that's pulled from the hub in this demo. So moving over to VS Code, while we analyze this, I'll just go ahead and apply it for the sake of time. All right, so in the policies namespace, I defined a secret. And this secret has 2 keys, cluster 1 app password and cluster 2 app password. So this should be set on a secret that we create for cluster 1, and this should be set on a secret for cluster 2. And so I'm defining my policy, and within that I have just the one policy template called configuration policy, of type configuration policy, I should say. And we are enforcing that we must have a secret called devconf demo in the default namespace. And there's just the one key that we're setting called app password. And then we're using a hub template. And so what you can see is that we're pulling from the hub a secret. Now the namespace is empty here, but you could set it to the same namespace as the root policy, but anything else would cause an error. And that's for that security restriction that I talked about before. And we can, and it's pulling from the devconf demo source secret, and then the field is dynamic. So in this case, there's a variable that is provided to you when you're doing hub templates called managed cluster name, and we can dynamically derive the field that we want to pull from the secret. In this case, it'll be cluster 1-app password and cluster 2-app password. And the placement that I have set is just, there's no label selector, which means it'll just apply to everything. And then there's a placement binding tying that placement to this policy. So I went and applied that earlier, so let's go take a look. So we can see that the policy is compliant. And let's just take a look at the root policy status. And we can see that the status for cluster 1 is compliant and cluster 2. Now, if one of these was non-compliant, then the overall status would be non-compliant. But since both are compliant, it is set to compliant. And because we were enforcing, the secret will be created. So let's switch over to the managed cluster. So this time it's cluster 1. We'll get the secret devconf demo. So you can see that was created. And it has app password set to this value. And if you recall, our cluster 1 app password on the hub was this value. And then I'll do the same thing for cluster 2. And you can see that the app password is set to that correct value. Now, what's going on behind the scenes bit, I'll show you, is that each managed cluster has its own AES encryption key, and so AES 256 is used to encrypt the value before it's stored in the replicated policy. So we can see that here. So you can do this on the hub or the managed cluster. So get the policy. Sorry, I gotta go in the cluster namespace. I'm on cluster 2 right now, but I could do this also on the hub as well. And so you can see that more detailed history of that. It wasn't found in the namespace, and then it created it successfully, and then later when it checked again, it found that it hadn't changed and it was correct. But what I wanted to show you is that there's this value here that was set from that template that we executed. This from secret. It's actually pulling, or it's actually encrypting this value with the AES encryption key, and so it's base 64 because it's binary, the encrypted value. As you can see, like there's nothing that comes out of it. And so, like I said, the encryption key is unique to each managed cluster, and it's automatically rotated every 30 days, so that you can trigger a rotation anytime. And so the reason why well, one of the reasons why we encrypt it is one, just because someone has view access to a policy to see the status doesn't necessarily mean that they should have access to view the secret contents, but also because if you enable etcd encryption, it's in custom resources such as policy or configuration policy won't be encrypted at rest in etcd, and so this way it's stored on disk in etcd encrypted. And if you're not familiar, Kubernetes uses etcd as its data store backend. And so I'll go back to the hub. And what I can do is let's just set a message. So we'll just say OCM policies, base 64 of that. So what I can do is I can actually edit that source secret that the hub template was referring to. Sorry, I'm in the wrong namespace. Let's try again in policies namespace. And so I'll just change cluster1 app password to this new value. And let's go ahead and go back to cluster1. And let's take a look at that secret again. And we can see that the value updated. And so what's happening behind the scenes is that on the hub cluster, it's watching that secret that you reference in the hub template. So this defconf demo source secret. So whenever it updates, it'll regenerate the replicated policy and then transfer that over to the managed cluster. And so you don't have to do anything. So anytime the secret updates, it'll propagate its way over to the managed cluster and then get applied. So going back to the slides now, this might seem like there's a lot of YAML that you're working with right now, and it can be a little overwhelming when you're first starting out. So there is a Kustomize generator plugin called the Policy Generator that really helps simplify writing policies, especially in a GitOps environment. Red Hat has a pretty good blog on this topic, but I'll just show you quickly the first demo that I had that rewrote into the Policy Generator logic. So let's go ahead and take a look at that. So if you recall, there's all this YAML here about in our first demo saying that we must have this defconf demo config map with this movie quote. But we can take a look at the policy generator folder. And so I'll just show you, this is just the config map on its own, similar to how you do like a kubectl apply, or if you were to use like Argo CD or something like that to apply it. And then we have this customization.yaml, which references just the one thing, which is a generator called the policy generator.yaml. And here is the configuration for the policy generator. So this is just boilerplate stuff that you have to provide for Kustomize to identify that you're specifying the policy generator as the plugin you want to use. But here we're just saying that we are setting the namespace to all of our policies to be the policies namespace. And then it's under policy defaults. And then we're saying for all of the policies that we generate, use this label selector of data center set to Boston. So only target the clusters that have this label. You could specify this lower below as well, but this makes it apply to all policies being under the defaults. And then I've just defined one policy. And so here I'm calling it defconf demo config map. I can disable the policy if I want to, but I'll just remove that. It's not necessary. And then I just have to point to the manifests that I want to have in my configuration policy. And so in this case, it's just the input directory config.yaml. I could have just specified the entire directory if I wanted to. And then there's this remediation action that I'm saying to enforce, because by default it'll be inform. And so let's go into that policy generator directory. So I'm just going to run Kustomize locally, but if you had like Argo CD configured with this, the Open Cluster Management application subscription add-on has it already built in and pre-installed, so you can use it there. But let's go ahead and we have to specify enable alpha plugins because that's how Kustomize enables non-native plugins. And so actually, let's wrap this in YQ so we can get the syntax highlighted. And so you can see that similar to example 1.yaml, we have that policy that was generated, the policy's namespace, it generated that configuration policy. It's saying that we must have, and it's enforced to have this config map of do or do not, there is no try. And then you'll see also that the placement was generated saying that only apply clusters with the data center label set to Boston, and then there's the placement binding that binds these the policy and the placement together. And so the syntax to do this is I just provide that config map, and then I just provide essentially this data here. So it's a lot simpler to start off with if you want to just do that, and then as you get more advanced, you can do you can set different configurations, such as like changing the compliance type to must only have or must not have, like I talked about in the first example. And you can, and if your team isn't very familiar with OCM policies, this is a great way to start introducing it, where you can just tell other people on your team to modify the config map directly. And then after you commit it, and then whatever your GitOps application that applies this, applies your YAML that can execute Kustomize, it'll just generate the policy with that new content in here. So that way, someone doesn't actually have to know like where the config map is located, where it's wrapped here in a couple layers, and instead they can just modify it here. And then because we have this metadata here, the policy will be generated as we expect. So I hope this session was helpful to provide you an intro of some of the things that the policy add-on can do. Highly recommend looking into our gatekeeper integration that I referenced earlier. But if you have questions, you can check our documentation on openclustermanagement.io. It's under the policy add-on. We also have a Slack channel in the Kubernetes Slack of Open Cluster Management. We have some community meetings. There's a YouTube channel. So if you want more help, please feel free to reach out. And again, hope this was helpful for you.